Hello guys, welcome to another video. In this video, we will see about MCP, Model Context Protocol, which was released by Anthropic, and there is a lot of buzz at this moment on MCP, right? So I've just gone through the documentation and I've tried to implement what they have mentioned in the documentation on my own for my own tool. So I'll try to explain my best on what is MCP and how to use and when to use it, okay? So if we see the definition, MCP is a open protocol that standards how the applications provide context to LLMs. So they say MCP is an open source protocol, right? So what is protocol? Protocol is nothing but the way two devices or the two applications communicate, right? So that's the protocol. I mean, the meaning of protocol is. So now if you see, they say like how the USB-C port has revolutionized this, the connectivity between the multiple devices, like USB-C port, right? We can use with USB-C port, you can connect to the charger, you can connect to the hard disk or anything. So it has revolutionized in how we connect to the multiple devices. So they just compare this MCP with the USB-C port in this paragraph. That's it. So why MCP? MCP helps to build agents and complex workflows on top of LLMs. So for LLMs, it is helping to build the agents and the complex workflows. So the next point is a growing list of pre-built integrations that your LLM can directly plug into. So let's assume there are multiple tools or the multiple databases for which our agents needs to use. So in case if you want to configure all those, then we can go with the MCP as well. I'll tell you what exactly is an architecture of MCP and everything. I'm just going through the points right now. In case if you want to have the flexibility to switch between the different LLM providers, then also you can use MCP. So it is the best practices for securing your data within your infrastructure. These are the 3 points they mention on why to use MCP. So if you look at this architecture, so this simple architecture, what this is, we have a MCP client here, and using MCP protocol, we are communicating with these MCP servers, and these MCP servers are connected to this data sources or tools or whatever we have. So this MCP architecture is divided into two parts. One is the client and another is a server. Server is a place where our tools, databases, anything whichever our LLMs have to use externally, because LLMs will not have knowledge about our specific organization, right? So they have to be provided with some kind of resources like a database or some tools. So those tools or databases will be there in our MCP servers. And the next thing is MCP client. Client is a place where our LLMs exist, and we will try to connect to those external data sources which exist in MCP server. So the request goes from client to the server using the MCP protocol. This is a high level about MCP structure. So I've just gone through this documentation and I have created my own MCP server and my own MCP client in my local machine. I'll show you that, okay? So if you see, I have a table called family, which have all my family information, me, my wife and my 2 daughters information. Okay. So LLM doesn't know about my family information. So this database acts like a tools for the LLM. Okay. Instead of directly connecting to the to the specific tool or a database, we are using MCP here. So these details of my database connection and querying from my database, I'm creating as a tool, and that resides on my MCP server. So if I go through this code, so this is my MCP server. Okay. If you see, I just created a tool, nothing else here. If you see, I'm getting the Postgre database connection here. That's it. As per the documentation, they suggest to create an object to this MCP class. And now if you go and check this MCP class in their package or in this MCP module, if you see inside MCP server, fast MCP server.py, this particular class exists, and it takes one argument which explains about this particular tool and all. That's it. I'm just passing this family string here and I got an MCP. So I have a tool here. What is the tool doing? It's just querying my database and getting the data is a data frame and returning it as a string. That's it. This is my specific tool which tells about my family. So how to make it as a tool? You know, in LangChain or anywhere we use @tool, right, to convert a method into a tool. Similarly, here we have to use @mcp.tool. Of this MCP, we have created an object to this fast MCP class. That's it. And now we have to use this mcp.run of stdio, transport equal to stdio. So what is this transport equal to stdio? So the communication should happen between the server and the client, right? So how should the communication happen? Using the standard input and output. There are multiple types of protocols, right? If you can use WebSocket, TCP, HTTP, multiple kinds of communication can happen. Here, as everything is running in my local, I'm just using STDIO. That's it. So this is how we create an MCP server. Inside this MCP server, I have a tool which connects to my database and gives the information about my particular family. That's it. That's it. A simple MCP server has been created here. Nothing else has been done. We have to go and create the MCP client here. If you see the architecture, as we have already seen, we have an MCP server and we have a tool as well. So we are done with this particular part. So now we have to create our MCP client here. That's where the LLM exists, and that's where from where we try to connect to the server. Okay. So now if I go to my another code, so I just created another package. I'll show you on how to create the package. I'm just trying to go through the code first. That's it. So I just have a client here. I named it as MCP client. That's it. Now I have a constructor, and inside which I have three arguments. One is the session, second is exit stack, and the third is anthropic, the model, whatever the LLM which you want to use. Right now I'm using anthropic model. Here you can use OpenAI model as well. And the session is used to connect to the server. So while connecting to the server, any server, we might communicate multiple number of times. We might connect to one tool and again to a database. There can be multiple requests which can send to the server and get the connection. Instead of sending multiple requests to the server, we can create a session and keep the connection in the session, right? That's an ideal way which is followed in Spark and everywhere, right? So that's what they are also following here. So they're creating a session here. For creating a session, they are using this particular client session class from MCP package. That's it. Now if you see, I have even given the description here. Client session to communicate with the server. Why do we need session? Without a session, the client would have to create a new connection for every request. Like whenever we have to connect to a tool from the client side, we have to again create every request every time, right? Instead, if we keep the session, we can get the connection to that specific server at one time. That's why we go with the session concept. So ideally, this exit stack is using this particular async exit stack. This is not an MCP package. This is a plain Python package. If you go here, this is from Python only. Okay, this is a Python framework. This particular async exit stack is a Python package only. If you see here, to connect to the servers or something, like we have one kind of class in Python which we can use. That's called async exit stack. And what it does, I have mentioned here. Async exit stack helps to manage async resources like database connections, network sessions, and all those things. To handle these kind of scenarios like database connections, network session, the file handlers, we can use this particular class from Python, not from MCP. This is not from MCP. It automatically cleans up the resources when they are no longer needed. Even if an error occurs, it ensures the proper resource cleanup is done. So if you see these two lines, like after connecting to the specific resource, we have to close the connection. When you connect to a database, we do close the connection, right? In the finally block. In the try, we connect to the database, we read the query, and again in the finally block, we'll do that connection dot close, right? So by using this particular class, we can close that connection automatically. Internally, it handles to close the connection. That's why they suggest to go with this. And I tried without thing, but it didn't work to me. Like it was not able to list the tools from my server. That was the problem I faced. I will show you that as well. So now the next method is connect to the server. We have a server and inside which we are hosting our tools, right? So we have to connect to the server. So to connect to the server from MCP, we are using this particular class, stdio server parameters. If you see, we are getting this from MCP to connect to any server. So here we have to pass the command, and then these two are the commands only, and then the environment variables if it has to use. If you see the command equal to Python, and the server script path is what we are getting as an argument to this particular method, which I will show you. Here we are just passing this particular family.py path. Literally we are passing the server path here. That's what will come into this particular variable. We are passing the server path. While running, I'll show you that. Now, if you see, we got this particular server parameters, okay, to connect to that server. Using those parameters, using this stdio client from the MCP package. So here these three lines of code is used to start the server, and then to set up the communication using input output. That's what we are doing, stdio. Okay, and then create the session. These three lines of code is used to start the server, communicate using IO protocol, input output protocol, and then create the session. If you see this exit stack variable, if you see what I'm doing, self dot exit stack, which is the second argument. I have tried something like this. Without this, I have tried. I mean, I was just trying to use this particular stdio client and then passing the server parameters and then getting this information. Here also I tried using this without using this particular piece of code. Just without, I mean, I just don't want to use this particular exit stack, and I tried to connect here. I got the connection. I was able to get the session as well, which is fine. I was able to list the tools as well inside this method, which is fine. I will show you that as well. But in the next method, I am not able to list the tools here. It was coming as empty. Only when I use this particular exit stack dot enter async context only, I was able to get the tools in the next methods. So this self dot exit stack is just our variable which we created. It is using this particular class, and we understood the purpose of this particular class. Now there is a method called enter async context in this particular class, async exit stack. If we go to this particular method, enter async, see we have this particular method inside this async exit stack class from the Python package. This is the Python stuff, not an MCP stuff. So I mean, the purpose is to just clean up the resources. That's why. So in this particular line, we are starting the server, MCP server. So from this stdio transport, I am just fetching the input output and how the write should happen and how the read should happen, these two variables, and using these two variables, I am able to get the session here. I am able to create the session by passing those two variables to this client session class. This client session class is from the MCP only directly. So inside this connect to server method, we are first getting the parameters and passing that server parameters and getting the starting the server, and from this we are extracting these two parameters, and using these two parameters passing it to the client session class, we are getting the session and we are initiating the session here. So this is just a boilerplate code. This is not any custom code which I have implemented. This is a boilerplate code to just get the session of that particular server, and we already understood why we need the session. Okay, that's it. Now from this session, if you print the list tools, we will be getting the list of the tools we have. Okay, that's it. So this particular method connect to server is used to get the create the session and list out the tools. That's it. So now we have the next method, process query, and this is where we are using the LLM. Now if you see, what are we doing? I'm just passing a query, whatever the query I have, and I'm passing it into these particular messages. That's it. Now if you see, I'm again listing the tools and I'm keeping that in the response. That's it. And I'm just iterating the tools and getting the tool name, tool description, tool input schema. Because while we are creating the tools in the server, if you see the tool description, tool return type, everything we are giving, right? So that the LLM can understand. So now we are just trying to extract that information here. That's it. Now we'll keep the available tools in this particular variable. That's it. And now we are triggering the LLM. If you see self.anthropic, what is self.anthropic? The variable which we created, and it is of this particular class. So to connect to the anthropic LLM, we have to use this particular class. So self.anthropic.messages.create, and which model, the number of tokens, the messages, the tools, that's it, and we'll get the response from the LLM. So this particular, the initial response we'll get from the LLM. So when we pass the tools and the query in these messages, LLM will understand that yeah, I have the tools, and for this query we have to use those particular tools. So now again, as LLM is deciding to trigger the tools, so now the next thing is we have to invoke the tools, right? LLM first decides that for this specific query I can't answer on my own, I have to use the tools. So now once LLM decides to trigger the tools, we have to trigger the tool. So if you see, I'm just extracting the response, iterating it here, this response.context, I'm iterating it. If you see, I'm just printing the response as well, so I'll show you in the logs. And in case if it's of text type, then just print as it is. I mean, append the response to this particular variable, and we are just returning it at the end. That's it. Now in case if it is of tool use, yes, it will be of tool use, because I am asking some personal question for which it has to use the tool. LLM doesn't know about my family information. In case if it has a tool use, I'm just from the content, I'm just extracting the tool name, tool arguments and everything, and using this session I'm just calling this particular tool, the call tool methods, self.session.call tool, and that response and that result I am again appending it as a message and again triggering the LLM. The rest we have triggered the tool manually because LLM has decided to trigger the tool. In case if LLM has decided to trigger the tool, we are triggering the tool, and then that response we are again creating another message, and that message if we pass to the LLM. So now what LLM does is LLM will have our query first, and then LLM will have in the second argument of the list, LLM will have the response from after triggering the tool. So we will get the data frame, and the data frame we are appending it as a string, right? So the string information of this whole table will be there. Okay, once it has, it can summarize based on our query. So it has the data from the tool and it has the query. So this particular second time triggering the LLM will just summarize the response based on our query using the tool output in a human readable language and respond to us. That's it. So here if you see, I have another method. I'm just trying to make a loop of the questions here. When I run, you will understand the purpose of this particular chart loop method. Inside this chart loop method only, we are calling the process query. Process query is what we have seen just now. Let's trigger in the LLM. Okay, that's it. And in case if you pass the quit, then just break or else just continue. That's what we are doing here, nothing else. And now we have this class, right? So I'm just creating a main method and I'm creating an object to that particular MCP class, and then I'm just first connecting to the server, and then I'm triggering the chart loop method, and inside this chart loop method we are triggering the process query. And if you see, this particular piece of code has async IO, await, async, all these parameters, because here we are interacting with the server. When you interact with the server, the request will be going and it will be coming. Sometimes it takes time to get the response, right? So to not time out, we use async and await and all those. This is just a Python stuff. You can just explore it from the internet. That's it. So now if you see, I have even explained that async and await handles tasks that take time, like reading files, making network requests. Whenever you have like communicating with the servers and all, we use this async and await. If the method is declared with the async, while calling that particular method, you have to use await, because this particular method connect to server as async. See, this connect to server as async. So we have to, while calling that particular method, we have to use await. I mean, it's just like when the response is going to take time, we use this particular Python stuff. That's it. Now, if you see, I'm just triggering the main method here. And if you see, I'm using async IO.run of main. Why am I using async IO.run? Async IO is a Python library that allows your program to run multiple tasks at the same time without waiting for one task to finish before starting another. And it's just a Python library, not anything related to the MCP. So we saw the code from MCP server where we have our tools, and we saw the code from MCP client where we are first getting the connection using these 3 lines of boilerplate code from MCP. Okay, and once we get the connection, we are using that particular session. I mean, we are getting the session, and using that particular session, we are just listing out the tools and we are passing the tools to the model, and the model is deciding, yes, for this query I have to use the tools. And in case if model decides that, we are manually triggering the tools and we get the response, and that result we are capturing and passing that to the LLM again using these messages. So LLM will summarize in the natural language. Okay, because that the information which I get is this particular whole data, right? We can't give this particular whole data to the customer when he asks the question. We have to summarize. So that's what we are doing. So first I'll just trigger this, and then I'll try to create the project. Okay, I'll show you on how to create the project. So if you see, I'm using UV. I mean, I'm using the UV package here. Instead of pip, we have UV, which people are using nowadays instead of pip, because it's a fast installation. It's just replacement of the pip. That's it. If you see, I mean, in case if you use and if you want to run any code, you have to use UV run. And in case if you want to add any package, you have to use UV add. Okay, like if how you use the pip install, like here you will do UV add. That's okay. And here UV run the this particular client family, and then the path of this particular server file. I have this particular file, right? The family.txt. So when I execute this, see, if you see here, connected to the server with tools, get family details. See, once we get the connection, connect to the server, here we are listing the tools. That print statement has been executed. Right now we have only one tools in our server. Only one tool, at the rate mcp.tool, only one tool, nothing else. That's why we got only one. So I'll ask the question, what is the age and date of birth of Praveen Reddy? Okay, I just asked this question. LLM doesn't know, it has to use the tool here. So when I enter processing query, we'll check these logs to understand the code. Praveen Reddy is 30 years and his date of birth is this one. So if I go here, I got this particular information, the first one, 30 and my date of birth I got. I'll ask what is the Praveen's favorite interest. What is Praveen favorite food? According to the family details, Praveen's favorite food appears to be biryani. Okay, so now if we see, how are we? We already got the connection to the server and we got the tools, right? So I asked the question. So then I got this particular entered processing query, because what we are doing in the main method, we are first connecting to the server and then we are doing this particular chart loop. And inside this chart loop, we are just entering the query using this input only. It is asking the query here, and if I don't type quit, it will come here. And here if you see, I'm calling the process query, this particular method, process query, right? And inside this process query, the argument is the query which we asked. It comes to the messages, and then we are just listing out the tools from the session, and we are passing all this information to the LLM. So LLM decides to call the tool. If you see the initial Claude response, if you see here, initially when we pass the tools and my initial question, if you see, it is using the type equal to tool use. That means if the type equal to test, we are just responding immediately. But LLM deciding to use the tool use here. So it comes to else if block, and here we are manually triggering the tool, and then we are appending this particular response again as a form of messages, and that message we are using to trigger the tool. That's it, and we are getting the response in this particular way. That's it. So I just gone through the code and I've showed you how to create an MCP server and a client, right? So let's see on how to create this particular project. Okay, so now I'll close this too. So I'll create inside this MMCCPP, I'll create two projects, one for client, one for server. So I'll use UV. Okay, I have UV installed. So UV init MCP client. That's it. Now again UV init MCP server. So I just created two folders. That's it. But inside which I like when you use UV, it just creates some toml file and a main file. Okay, but nothing else has been happened. So now we can just open both using this VS Code. So now let me create a virtual environment. Here also I will create UV VNV virtual environment in both. That's it. I just created a virtual environment in both so that we can install all the packages using UV. So now let me activate that. Okay, let me activate this virtual environment. I activated here even in server as well. That's it. I just activated my virtual environment, and now I can install the packages I want. Okay, so to install, like in using pip, we use pip install. Using UV, we will use UV add the packages I want. I want MCP CLI, right? So if you see, I just created two folders, one for MCP client and one for MCP server using UV, and then I created the virtual environment in both, and I just activated those, and now I'm just trying to install the required packages. If you see UV add MCP CLI, MCP package, Anthropic package, Python.env package, and then SQL Alchemy package, because if you see, we are using SQL Alchemy to connect to Postgres, and then PSY COPG2, because that's what we are using to connect to Postgres, right? So I just installing all those packages. That's it. Like it's faster than pip, right? So I just installed the same in the server as well. That's it. Now we are coming to the client. I'm just clearing up, and we don't need now, and I'm just clearing up here as well. That's it. And now we have to create our own Python file. So I'll just use touch family.py. Now here also I'll just use touch family client.py. That's it. I just created these particular Python files. Now I need to copy paste the code. Okay, I just copy pasted the code. Now I'm just running the code. Okay, to run the code, you will run this particular Python file and then the argument, and this argument is used here, if you see, to go to pass it to the connect to server, because we have to pass the server path, right? So that's what we are doing in this connect to server, and we are getting that particular path, and using that particular path we are getting the server parameters, and using server parameters we are creating the session using these 3 lines of boiler code. That's it. So now when I run it, oh, I forgot to install pandas module as well. So uv add pandas, let me do the same as well here. uv add pandas. We don't need to install it here, we have to install only in the server. We got the connection, which is fine, but I guess I could not resolve authentication method. That means the Anthropic which we are using here, it has to have the API key, which I did not keep in this .env file. So I'll just create a new file, .env. That's it. Now in the git ignore, where is git ignore, I'll add .env as well, .env, because it doesn't go to my git. That's it. Now inside this I'll keep the Anthropic API key. We run this again. I got it. What is the age of Praveen Reddy? Now it is able to use the LLM properly. According to family trees, Praveen Reddy is 30 years old and his date of birth is, that's it. So this is how we just create a simple client and the server. Here is inside the server we do have all the tools. Right now I just created a simple tool. You can have any kind of tools, database connections and everything you can keep in the server, and using the protocol, because MCP is a protocol framework, right? Using this MCP protocol framework only we are able to connect to the server, MCP server. Inside the server we can keep on adding the tools, and number of tools as the organization grows, the tools can be added based on the projects and all. That's it. This is what the POC on MCP is. That's it. Thank you so much for watching.